Something is buried beneath the moon that should not exist. Not a crater, not a rock formation, not ice. Something so dense, so massive, so wrong that it is physically pulling the moon's surface downward by more than half a mile. And in 2019, China landed directly on top of it. What their rover found in the weeks and months that followed has quietly rewritten everything scientists thought they knew about where the moon came from and what it's actually made of. We're going to get to the full reveal, but I need you to stay with me until the very end of this video, because the final piece of this story is the part nobody is talking about. Before we go any further, where are you watching this right now? Drop it in the comments. I'm genuinely curious how far this one travels. Now, let's go back to the beginning. The far side of the moon is not the dark side in the way most people picture it. It gets sunlight. It has days and nights just like the near side. What makes it dark is something else entirely. You cannot see it from Earth, ever. Not once in human history has a single person stood on this planet and looked up and seen the far side of the moon. The moon is tidally locked to Earth, meaning it rotates at exactly the same rate it orbits, so the same face is always pointing toward us. The other side, completely hidden. And for a long time, completely unreachable. Not because we lacked rockets, we had those. The problem is communication. Radio signals travel in straight lines. The moment a spacecraft disappears behind the moon, you lose it. 2,000 kilometers of solid rock between you and your spacecraft, and there is absolutely nothing you can do about it. So for decades, the far side stayed untouched. Then China came up with a solution. In 2018, they launched a relay satellite called Qichao, which translates to Magpie Bridge, named after a Chinese folktale about two lovers separated by the Milky Way, reunited once a year when magpies form a bridge with their wings. Qichao was designed to do exactly that, bridge the gap. It was placed at a special point in space called the Earth-Moon L2 Lagrange point, roughly 65,000 kilometers beyond the moon. From that position, it can see both Earth and the far side simultaneously. It was the first relay satellite ever placed there, and it changed everything. 7 months later, Chang'e 4 began its descent toward the surface. The landing site was a place called the Von Karman crater, located inside the largest confirmed impact structure in the entire solar system, the South Pole Aitken Basin, 2,500 kilometers across, deeper than the Himalayas are tall, so enormous you cannot see all of it at once even from orbit. It formed about 4 billion years ago when something the size of a small planet hit the moon so hard, so fast, that scientists believe it may have punched all the way through the crust, all the way down to the mantle. That's the layer beneath the crust, the stuff that's never supposed to be exposed at the surface. And that is exactly where China chose to land. On January 3, 2019, at 2:26 in the morning GMT, Chang'e 4 touched down, the first spacecraft in human history to land softly on the far side of the moon. NASA called it impressive, scientists around the world called it uncharted territory, and then the rover rolled out and almost immediately started finding things that didn't fit. The rover is called Yutu-2, Jade Rabbit in English. It weighs about 140 kilograms, moves slowly, looks almost fragile against the vast gray emptiness of the lunar surface. But it's loaded with instruments, cameras, radar, spectrometers, and it started working immediately. The first major surprise came from the soil itself. Yutu-2's spectrometer began detecting minerals that weren't supposed to be so close to the surface in such high concentrations. Olivine, pyroxene, low-calcium pyroxene. These are mantle minerals, materials from deep inside the moon, not the crust. This was exactly what scientists had hoped for, but weren't certain they'd find. The South Pole Aitken impact may genuinely have been deep enough to expose the moon's interior. That alone would have been enough to make the mission historic. But then came the glass. In early 2022, scientists analyzing images from Yutu-2 spotted something sitting on the lunar surface that stopped them cold. Two small spheres, translucent,
almost like marbles, glistening against the dry, gray dust. Glass has been found on the moon before. The Apollo astronauts brought samples back, but those were dark, opaque, solid chunks. These were different. You could nearly see through them. The lead scientist on the mission said, and I'm paraphrasing here, that these objects simply blew their minds. They were unlike anything previously documented on the moon. Glass forms when rock is superheated instantly, like during a meteor impact. The molten material gets thrown into the air, cools rapidly in the vacuum of space, and solidifies. Scientists call them microtectites. But these were larger than typical microtectites, and they were transparent. The researchers believe they formed from a type of rock called anorthosite, a feldspar-rich mineral extremely common on the lunar surface that melted and reformed in the immediate aftermath of an ancient collision. And here's why that matters beyond just being scientifically interesting. Those spheres are essentially proof that the moon's surface contains raw materials capable of producing high-quality glass, windows, lenses, solar panels. Future lunar bases wouldn't need to ship glass from Earth. They could make it there from what's already on the ground. But the glass was just the start, because then researchers analyzing samples, not from the far side yet, but from the Chang'e 5 mission on the near side, confirmed something that genuinely shocked the scientific community. Natural graphene. On the moon. Graphene is a single layer of carbon atoms arranged in a honeycomb structure. It's one of the strongest materials ever discovered. It conducts electricity better than copper. It's extraordinarily thin. When it was first isolated in a laboratory in 2004, the scientists who did it won the Nobel Prize. And it was sitting in lunar soil. The researchers confirmed it using multiple high-precision techniques. The graphene wasn't thick, just 2 to 7 atomic layers in some places, but it was there, embedded in the regolith, in some cases forming shell structures around complex mineral cores. This was not supposed to be there. For decades, the dominant scientific view was that the moon is carbon depleted. The giant impact that created the moon, when a Mars-sized body called Theia smashed into the early Earth, would have vaporized volatile elements, including carbon, stripping them away. Finding graphene challenges that model directly. And then in 2024, China went further. The Chang'e 6 mission, the first ever sample return from the far side of the moon, landed in the Apollo basin, deep within the South Pole Aitken Basin, collected samples, and brought them home. Researchers analyzing those samples found single-walled carbon nanotubes. Carbon nanotubes are cylindrical structures made from rolled-up graphene sheets. In terms of material properties, they are almost absurdly impressive. Stronger than steel, lighter than aluminum, extraordinary electrical and thermal conductivity. Until this discovery, carbon nanotubes were thought to be exclusively a product of human engineering, something built in laboratories. But there they were, in lunar soil. The researchers confirmed it using multiple high-precision techniques. The nanotubes weren't thick, just single-walled in some places, but they were there, embedded in the regolith, in some cases forming shell structures around complex mineral cores.
Now we come back to the anomaly, the thing that started this whole story. In 2019, the same year Chang'e 4 landed, researchers at Baylor University published findings from NASA's Grail mission, which had spent years precisely mapping the moon's gravitational field. When they combined that gravitational data with surface topography measurements, the result was something they couldn't explain. Deep beneath the floor of the South Pole Aitken Basin, beneath where China landed, there is a concentration of mass so extreme, so dense, that it is physically pulling the basin floor downward by more than half a mile. The lead researcher described it this way. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That's roughly the scale of what they detected. So what is it? Theory 1. It's the iron-nickel core of the asteroid that created the basin 4 billion years ago. The object hit with such force that its metal core didn't bounce back into space. It buried itself into the moon's mantle and has been sitting there ever since. Computer simulations show this is physically possible under the right conditions. Theory 2. It's a concentration of dense metal oxides that crystallize during the final stages of the moon's magma ocean solidification, a kind of frozen remnant of the moon's earliest molten history. Both theories are legitimate. Both have supporting evidence. But here is what makes this genuinely unsettling for scientists. China has now landed in that basin multiple times. Chang'e 4 in 2019, Chang'e 6 in 2024, Chang'e 7 is scheduled for around 2026. They have collected samples, they have mapped the terrain, they have analyzed the soil, and they have not yet publicly stated what they believe the anomaly actually is. That's not a conspiracy. Science takes time. Samples are still being analyzed. Data takes years to process fully. But the silence is notable. Because if those samples contain mantle material, true deep mantle material from hundreds of kilometers below the original lunar surface, then what China has in those sealed containers back on Earth could directly answer one of the oldest questions in planetary science. How did the moon actually form? The current model, the giant impact hypothesis, says Theia hit the early Earth and the debris formed the moon. But there's a problem. The moon's chemical composition is almost identical to Earth's. Same oxygen isotopes, same titanium, same iron. If Theia came from a different part of the solar system, the moon should look different to Earth. A study published in November 2025 in the journal Science addressed this directly. Researchers analyzed the iron isotopic ratios of Earth rocks and Apollo lunar samples with extraordinary precision. Their conclusion: Earth and the moon are isotopically undistinguishable, and the most likely explanation is that Theia and Earth formed in the same neighborhood from the same raw materials in the inner solar system. Neighbors, not strangers. Which raises a deeper question. Why did Theia collide with Earth all at all? One leading idea is that Theia formed at a Lagrange point in Earth's orbit, a gravitationally stable position, and remained there for millions of years. But as it grew larger, gravitational nudges from other planets slowly destabilized its orbit, and eventually, inevitably, it fell into Earth. That collision gave us the moon. It tilted Earth's axis and gave us seasons. It may have helped generate the magnetic field that protects life. And it buried a mystery 4 billion years ago beneath the largest crater in the solar system. A mystery that's still there. A mystery that China is right on top of. Whatever is buried beneath the South Pole Aitken Basin has been there before life existed on Earth. It survived 4 billion years of silence. And now, for the first time, we have robots on the surface above it, drilling, sampling, scanning. We don't have the answer yet, but we are closer than we have ever been. The feed didn't cut, the data is real, the discovery is ongoing, and the next mission launches in 2026. If you're still watching, thank you. Share this with someone who would actually want to know this, and drop a comment telling me which part of this hit you the hardest. Because we're going back to the moon, and this time, we're not leaving.